This is video 2. Remember, before we left, I asked you to cut and arrange the following. So you should have the top of yours that's a type of transport and the directions. You have the trifold and the bottom piece. Remember, it pops up, so the little tab should have fit under this portion and glued down so that when you look at it, you know what's going on. As the directions indicate, you're going to use it as a legend and color code the following. It says, use the key to complete the coloring. You are going to label the three either simple diffusion, osmosis, or facilitated diffusion, and color code the hydrophilic heads, hydrophilic tails, carbon dioxide, ions, water molecules, sugar molecules, proteins, and you're going to indicate the arrow, which indicates if you're going from high to low and where the higher concentration is versus the lower concentration. So, if we look at our first one, it asks you to color the little shaded areas of water molecules. So we have water molecules, and we're talking about water only. There's no other molecules present here. So you can see that we're dealing with water. And the type of passive transport that deals with water is osmosis. So if we think about that, where do we see more bubbles? We see 1, 2, 3, 4 here and 3 here. The higher concentration would be here, so that's why I wrote the H to indicate higher concentration. And in osmosis, which is a type of diffusion, or let me say passive, we're going from an area of higher concentration to lower concentration. So you can see that I drew my arrow going from high to low. Let's look at the next one. In the next one, it looks very familiar. We see some proteins involved in here. We have protein channels and carrier proteins involved in here. So you can see that the molecules that we're trying to get across are glucose and iron. And we're trying to see what area is going to be high versus low. And since they're getting some help, we're going to call this facilitated diffusion. So if we look at the bottom, we have more glucose and iron molecules at the bottom of the picture. We have 4, and then we have 1 sugar molecule here and 3 iron molecules here. So we're going to be going from an area of higher concentration to an area of lower concentration with the help of our protein channels. So we can see that this molecule is too big to get across by itself, so it's going to allow that channel to open up to allow those glucose molecules to go through, and this protein channel is going to allow those iron molecules to go through here. So it's going to need some assistance. It can't not easily flow like water did in the first one. The second one talks about simple diffusion. So simple diffusion is talking about gases. Remember, we talked about oxygen, carbon dioxide. In this particular one, they wanted you to do carbon dioxide. So you can see my little molecules of carbon dioxide are coded orange. And if you look here, I have more carbon dioxide molecules at the bottom than the top. So I'm going from an area of higher concentration to lower concentration. Using this model, I'm asking that you try to answer the questions below. They asking you about passive transport, talking about concentration gradients, carrier proteins, aka channel proteins, talking about permeability. So you should be able to not only tell what the ones were above, give a description of them, and fill in the blanks. And we'll go over those when I get back on Tuesday.